Region specialists have tracked down that using our new $10 billion toy, the flight plan could take an extraordinarily expansive turn before it will turn out to be a reality. On the remote possibility that it goes as indicated by plan, the visit to Proxima might take around different years. All things considered, it will maybe be a few years sooner than we can affirm if there can be sure life on that planet. The format request remains: would it be really smart for us to impart that we are isolated in this universe? The Webb Space Telescope has tracked down a few non-human-like things some distance from Earth, directing us toward strategic response. Our trip for presence beyond us has been a first concern for the extent of each single human progression, to such an extent that we have suspended a genuinely gigantic number of media works and hypotheses as we contemplate our wonder with appreciation for our area and separation in the universe. This has been standard, as it's far amassed inside us to diligently look for a friend. Even if outsider-like, unquestionably, we should ponder more. The responses we seek might someday be the responses we are endeavoring to find, or they might be incredibly disturbing. Come nearby as we evaluate the sharp disclosures in the country states of universes and planets in the experience to find something we may not be shaped to see. Lighting far off, researchers have sorted out what might actually be the best significant openness ever in 2021. At the moment that the James Webb Space Telescope was launched, a completely enchanting theoretical question was raised about the limits of our advancement. The question was whether our telescopes should see artificial signs on another planet, close by Proxima B. Proxima B, the nearest exoplanet to Earth, is in the habitable area of our nearest neighbor, the relatively unknown star Proxima Centauri, 4.24 light-years away. Since the exoplanet is just a few degrees closer to its warm star than Earth is from the Sun, Proxima should be tidally locked, with a perpetual dayside and nightside like our Moon. Speculative high-level human advancement on Proxima B could pass warmth and energy from the dayside to the nightside using photovoltaic cells that produce power from starlight. A paper with Manasvi Lingam as one of the specialists showed that extensive use of the dayside through solar cells could be associated with future telescopes. Considering that the Webb Space Telescope was developed, it allowed us to advance our plan and devices to study exoplanets like Proxima. Over time, as the James Webb Space Telescope continues its mission in 2024, it is expected to use its higher sensitivity and more significant arrangement of focal points to identify the lighting structures we were looking for, possibly ushering us into a new era of human advancement. This would allow us to delve into the universe of planets and exoplanets to see how this was even possible. James Webb's primary objective is to examine Proxima and its secrets. Throughout time, people have wondered about the nature of the universe. What are we? Where do we come from? Where are we going? These are common yet very hard questions that humanity has endeavored to answer since it gained consciousness within the time of stimulating inventive advancement. One wonders whether we are any closer to any of these mentioned questions. If you ask a realist, they might say we are still at stage 0 of knowing ourselves within the universe. However, ask a regional expert the same question, and watch them weave around in excitement as they race to enlighten you about the most unbelievable discoveries humans have made about the universe using their rapid technological tools. These tools, though not widely recognized by the general population, are a testament to human advancement. We now have the region actually available to us, and it's time we push forward and explore the universe. It is only natural to do what has been done through professionals and cosmologists. It is through this advancement that we tackle a specific phenomenon, one that is now responsible for the new discovery of what might be lights on another planet light-years away. Yes, we're reviewing the James Webb Space Telescope. The James Webb Space Telescope is the creation born out of the practices of human missions into space to address several capable questions. Are we alone? Where did we come from? And where might we be going? This infrared space astronomy device has already begun answering these questions, albeit with a few confirmations first. You might find yourself asking, what even is Proxima B? Proxima B, sometimes known as Alpha Centauri b in Earth's context, orbits an M-type star. Super-Earths are a class of planets that are possible but more massive than Earth, yet lighter than ice giants like Neptune and Uranus. They are thought to be composed of gas, rock, or a mixture of both. Their sizes can range from twice the size of Earth to 10 times its mass, and they often resemble Earth. Proxima B's mass is believed to be roughly 1.07 Earths, and it takes approximately 11.2 days to complete one orbit of its massive star, compared to our 365.25 days. When you look at the characteristics of the giant star, Proxima B's surrounding environment is particularly under the assessment of the entire electromagnetic spectrum. The star has a total luminosity of only about 0.16% that of the Sun. Additionally, in the visible spectrum, its luminosity appears significantly dimmer, as it illuminates just 0.056% of the Sun's brightness. Furthermore, the majority of its emitted energy is in the form of infrared radiation, comprising over 85% of its output, spanning 0.48 to 6 micrometers. Proxima B's discovery was made way back in 2016. You might be curious about the reason why Proxima B, among a multitude of stars, planets, and systems, garners so much attention. There are several reasons contributing to astronomers' keen interest in Proxima B over others. Firstly, it is the nearest star to our solar system, despite the fact that 4.24 light-years is still a considerable distance for us Earthlings. Within the grand scheme of the universe, however, it is a mere blip. Consequently, Proxima B, our closest star, ranks high on the priority list. Is also an integral part of the star system called Alpha Centauri. Despite Proxima B's low brightness, the system itself is one of the most prominent star groupings in the night sky, surpassed only by Sirius and Canopus. However, the most intriguing aspect of Proxima and Proxima B is that it is potentially habitable, as it falls within the habitable zone. The potential is limitless, considering its proximity to a massive star. Thus, astronomers have taken on the challenge of exploring the depths and boundaries of Proxima B's capabilities. This is where the James Webb Space Telescope comes into play. As the JWST continues its assessment of the exoplanet, we move ever closer to the culmination of these missions, from SETI to exoplanet research in the search for extraterrestrial life. So, what exactly is SETI? Humans have always been a curious species, grasping and interacting with everything that moves or doesn't move. It's no surprise that an endeavor like SETI emerged with such remarkable breadth and vision. However, instead of searching for gold, we're on a quest for signals, especially electromagnetic whispers from civilizations beyond anything we might have ever considered. SETI aims to search for extraterrestrial intelligence, and it is our system's mission to detect signals and evidence of advanced life forms lurking among the stars. Our mission traces its roots back to the early 1900s, right after the radio age dawned upon humanity. Pioneers like Nikola Tesla and Guglielmo Marconi had incredibly specific ideas. They hoped to use those inventive devices to establish interstellar communication. Tesla even entertained the possibility of communicating with Martians using his wireless transmission device. Fast forward to the 1960s, and we find ourselves in the midst of Project Ozma, the brainchild of the eccentric astronomer Dr. Frank Drake. Armed with powerful telescopes, Drake scanned the vast reaches for signs and evidence of something occurring. Unfortunately, his efforts didn't yield much. The mission, however, led researchers to tune their antennas to the cosmic symphony. Meanwhile, in the Soviet Union, our colleagues across the Iron Curtain were equally enthusiastic about the grand cosmic chatter. Soviet scientists turned their antennas up, searching for those elusive transmissions from the stars. Thus, the stage was set for a perpetual contest. But what was this high-quality signal that emerged amidst the cacophony? The conversation reached new heights with the discovery of the WOW signal. It sent shockwaves through the established community of researchers. As the years passed, the search for extraterrestrial communication only escalated, from SETI to the MWA Murchison Wide Field Array Hugg Cyclopes. Researchers went all out in their quest to solve the great mystery. Then, in a fortunate turn of events, or perhaps destiny, a coded radio transmission from Mars through telescopes reignited the discussions. However, what does that assessment reveal now, and how have some progressed regarding missions to detect lighting structures on Proxima B? In a 2021 research paper titled Visibility of Artificial Lights from Proxima B, researchers Elisa Tabor and Abraham Loeb attempted to explore the possibility of detecting artificial lights emanating from the dark side of Proxima B. Given that Proxima B is located within the habitable zone of its massive star, They aim to determine whether Proxima B could potentially host intelligent life and how to identify it in the future. Given Proxima B's significance as a viable candidate in the search for extraterrestrial life, they developed a meticulous yet innovative approach. The recent theoretical radio transmission discovery from Proxima B's vicinity was not quite as recent as it was initially thought. In 2019, a group of scientists collaborated with Breakthrough Listen, an initiative dedicated to the search for extraterrestrial signals, and observed a faint signal emanating from the vicinity of Proxima Centauri. It appeared to be an artificial transmission originating from the region around Proxima B. The signal was discovered to be a narrowband radio wave, as the narrowband was typical of man-made transmissions, making it a potential candidate for extraterrestrial intelligence. Although the source of the signal remains unknown, it has been aptly named the Breakthrough Listen Candidate 1, which now fuels our curiosity as we contemplate the possibility of it being a signal from another civilization in our cosmic neighborhood. Fast forward to the anticipated James Webb Space Telescope, whose mission is to detect the lighting structures on Proxima B that could indicate intelligent life. With the launch of the James Webb Space Telescope in 2021, researchers have refined their techniques, and the stage is set for a groundbreaking discovery. The Webb Telescope will push the boundaries of what's known, capturing images and information that will shape our understanding of our place in the universe. As the telescope scans the skies, its mission is clear: to find the lights of Proxima B and bring us closer to the ultimate answer. Are we alone in the universe?